Professor Gaurav Gupta sir again. I've hosted him. I've been a moderator for another session of his that was for how data is helping for in healthcare sector itself. So he took up a topic of skin cancer that day itself, even other cancers itself, and he told us how this data can help, or how machine learning or how deep learning can help in recognizing cancer at earlier stages, right? Dr. Professor Gupta, if I talk about Dr. Professor Gupta, he's a professor in the field of computer science in Shoolini University. He's a research fellow in the field of AI and ML. He's published many papers itself. He's a regular member of IEEE, right? And he's always been very insightful about all these topics. His research is also, he's pursuing the research in this particular field also, how this new technology is useful in healthcare sector itself. With that, Professor Gupta, you can continue itself.
Thanks,
yeah,
Rohit, for the short and crisp description. This is
my pleasure. My pleasure. Yeah, please.
No, wait for a second, please.
Yeah. Yeah, good to go.
Okay. Welcome you all for today's topic, that is data preparation and analysis. Today we are going to talk about how data gathering and preparation has been done. Okay, starting from the big data analytics. As the data, we know what is the volume of the data. One has to deal with has exploded to unimaginable data. Means unimaginable amount of data from social media, from other type of data, from flight recorders, from vehicles, or even from games, from internet and power electronics data are readily available around the clock today. The big data analytics largely involves collecting data from different sources. Means today we are talking about the gathering of the data. Manage it in a way that it becomes available to the consumed by analysis purpose, and finally deliver data products useful for the organization or in the business purposes. Means from the raw data to the processed data and from the meaningful data, how we are going to analyze the data in that particular field. That is known as the big data analytics. So means the next part of this topic is CRISP DM methodology. CRISP DM methodology means cross industry standard process for data mining. This is a particular cycle which starts from the data and ends to a deployment of that data, in particular that field of business. Take a look at the following illustration that we have shown in this diagram. It shows the major stages of cycle as described by the CRISP DM methodology. Means they are interrelated to each other. Starting from the data from the business understanding. The initial phase is business understanding. You have to understand to which part of the business you are going to gather the data. The initial phase focuses on understanding the project objective and requirement from a business perspective, and then converting this knowledge into a data mining problem definition. Whether it is a business perspective or a research perspective, you have to understand what type of data you should gather and from where you should gather the data. A preliminary plan is designed to achieve the objectives. A decision model, especially one built using the decision model annotation, can be used here in business understanding. The second part we go through, that is data understanding. We have gathered the data, now we have to understand the data. The data understanding phase starts with an initial data collection and proceeds with activities in order to get familiar with the data. Means to identify What is the quality of data? What are the problems to the data quality? To discover first insight into data and to detect interesting subsets from that particular data and those hidden information, those are come with the data. Third part is data preparation. Means first two part is for the data understanding and for the gathering only. Now the preparation, how you prepare your data. The data preparation phase covers all activities to construct the final data set. Means data that will be fed into the modeling tools from the initial raw data. That is the particular data preparations. That data preparation tasks are likely to be performed multiple times. Means each time you need a new type of data set and not in any prescribed order. There is no order of data preparation. Task includes tables, records, attribute selection, as well as transformation and cleaning of data for modeling tool. Next is modeling. We have prepared our data. Now the phase comes to be modeling. In this phase, various modeling techniques are selected and applied, and their parameters are calibrated to optimal values. Typically, there are several techniques for the same data mining problem. Some techniques have specific requirement on the form of data, and some phases are different for different data set. After modeling, we have to evaluate the data, means evaluation of the model. At this stage in the project, one has to build a model that appears to have high quality from the data analysis perspective before proceeding to the final deployment of the model. It is important to evaluate the model thoroughly and review steps executed to construct the model. A key objective is to determine if there is some important business issue that has not been sufficiently considered. We have to evaluate all the possible issues that has to be raised by a client or by the model. At the end of this phase, a decision on the use of data mining results should be reached. Last is the deployment of the model or last phase of the cycle. Creation of the model is generally not the end of the project, even if the purpose of model is to increase knowledge of the data, or the knowledge gain will need the organized and presented in a way that is useful for the customer or the researcher. Depending on the requirements, the deployment phase can be as simple as generating a report or a complex implementation. Next part is big data life cycles. How the life cycle of a big data or a data gathering comes out to be. What are the basic steps that has to be considered into the life cycle? First is business problem definition or research problem definition. We have to define the problem, on which topic we are going to work. What is the brief area of the broad problem? This is a point common in traditional bioinformatics or big data analytical life cycle. Normally, it is a non-trivial stage of a big data project to define the problem and evaluate correctly how much potential gain it may have for an organization. Means if we have chosen a particular problem, it is going to be benefit for the organization or the research or not. It seems obvious to mention this, but it has to be evaluated. What are the expected gains and cost of the project? Next part is research. We have to do what is the research? Analyze what other companies or what other researchers have done in the same situation. This involves looking for solutions that are reasonable for your company, organization, or the lab. Even though it involves adapting other solutions to the resources and requirement that has to be considered. Particularly, we consider the methodology for the future stages should be defined in this research stage. Next part is human resource assessment. Means once the problem is defined and the research and methodology is defined, we have to identify the human resource. It's reasonable to continue analyzing if the current staff is able to complete the project successfully or not. Traditional bioinformatics or BI teams might not be capable to deliver an optimal solution to all the stages. So it should be considered before starting the project if there is a need to outsource a part of the project or hire more people. We can outsource the chunks from the projects, or we can hire the people who have the capability to complete those tasks. Next is data acquisition. Acquisition means this is the key section. We have to gather the data of meaningful data. This section is a key in the big data lifecycle. Means it defines which type of profiles would be needed to deliver the reluctant data product. Means data gathering is a non-trivial step of process. It normally involves gathering unstructured data from different sources. We have to gather data from different sources, and it might be in unstructured form. To give an example, it could involve writing a crawler to retrieve reviews from a website. This involves dealing with text, perhaps in different languages. While crawling over the website, it might be in English, Hindi, or any type of languages you are dealing with, normally requiring a significant amount of time to be completed. Next is data mugging. Data mugging is once the data is retrieved, for example, from the web, it needs to be stored in an easy to use format. To continue with the review example, let's assume the data is retrieved from different sites where each has a different display of the data. In order to combine both the data sources, a decision has to be made in order to make these two representation equivalent. For example, if we have the equivalent size representation like 1 and 2 in one part, and same 1 and 2 represented like with comma in another part, then how we are going to deal with this type of structures or this type of symbols? We have to make a equivalent representation. This can involve converting the first data source response to the second form or vice versa. Next one is data storage. Once the data is produced or processed, it sometimes needs to be stored in a database. The most common alternative is using the in big data is Hadoop, or we are using some SQL, MongoDB, Redis, Spark, or any of the form you can use here to store the database. This stage is most important in this part. It is not even an essential stage. This is not an essential stage to do where we have to store the data, but it is an important part. It is possible to implement a big data solution that would be working with real-time data. So in this case, we only need to gather data to develop the model and then implement it in a real time. Next is EDA, or exploratory data analysis. Once the data has been cleaned and stored in a way that insights can be retrieved from it. Means now the analysis part, this is the EDA part. Once we have stored the data, we have cleaned the data, we have normalized the data, now it is the retrieving of the data. The data exploration phase is mandatory. The objective of the stage is to understand the data. This is normally done with statistical technique and also plotting the data, means visualizing the data. This is a good stage to evaluate whether the problem definition makes sense or is feasible or not. What we have done in a problem definition, we are going to be evaluating in the EDA phase. Next is data preparation for modeling and assessment. After EDA, after cleaning, preprocessing in EDA part, we are going for data preparation for modeling. This stage involves reshaping the clean data, retrieving previously and using statistical preprocessing from missing values imputation. We will go into deep for missing values, outlier detection, normalization, feature extraction, and selection. We have to select all the features from the data, and we have to select the optimal features that has to be contributed while modeling the data. Next is modeling. The prior stage should have produced several data sets for training and testing. Means data preparation stage will produce a number of data sets. For example, a predictive model. This stage involves trying different models and looking forward to solving the business problem at the end. In practice, it is normally desired that the model would give some insights into that particular problem. Finally, after trying all the models, the best model or the combination of model is selected, evaluating its performance on a left out data sets. Last part is implementation. What we have gathered all from the problem definition to the modeling stage, we are now going to implement that in the last part. In this stage, the data produced or developed is implemented in the data pipeline for the company or the research problem. This involves setting up a validation scheme while the data produced is working in order to track its performance. Or we can say, the case of implementing a predictive model, this stage would involve applying the model to new data, and once the response is available, evaluating the model. Next part is big data analytics or methodologies. What we have to find, what we have to follow while we are analyzing our data. Don't confuse by the name big data. It is just data analyzing or something. We are visualizing the data. In the terms of methodology, data analytics differ significantly from the traditional statistical approach of experimental design. Analytics starts with data. Normally, we model the data in a way to explain a response. The objective of this approach are to predict the response behavior or to understand how the input variable relate to the response. What we have inputted will correlate to the response or not. Normally, in stats experiment design, an experiment is developed and data is retrieved as a result. In this part, one of the most important tasks is statistical modeling, meaning supervised and unsupervised classification or regression problems. Once the data is cleaned and reprocessed, available for modeling, care should be taken in evaluating different models with reasonable loss matrices, and then the model is implemented. Further evaluation and results should be reported for that particular modeling. For this methodology, we are divided into the 4 sections like core deliverables, key stakeholders, data analyst, and data scientist. What are they? We are talking about these now. First is core deliverables. As we have discussed in the life cycle of the big data, the data that results from developing a big data product are in the most of the cases such as machine learning implementation. We use in machine learning implementation the data we have gathered. Recommender system. The objective is to develop a system that recommends choices based on user behavior. You are well versed with Netflix, Amazon, Facebook. For example, Netflix is a characteristic example of this data product, like where based on the rating of the user, other movies are recommended to you or for the user data using Netflix. That is dashboard. Business normally needs tool to visualize aggregated data. A dashboard is a graphical mechanism to make this data accessible. Ad hoc analysis. Normally, business areas have questions, hypotheses, or myths that can be answered while doing ad hoc analysis with the data. Another is stakeholders. Stakeholders. What do you mean by stakeholders? Stakeholders like check who and where are the sponsors of other projects similar to the one that interests you. These are the stakeholders type. Example, having personal contact in key management position helps. So any contact can be triggered if the project is promising. Who would benefit from your project? Who would be your client once the project is on the track? You have to identify that stakeholder. Develop a simple, clear, and exciting proposal and share it with the key players in your organization. Then only you are going to have some stakeholders for your project. Next is data analyst. Many organizations nowadays struggle hard to find competent data scientists in the market. It is, however, a good idea to select prospective data analysts and teach them the relevant skill to become a data scientist, as we are taking the webinar right now. This is by no means a trivial task and would normally involve a person doing a master's degree in quantitative field, but it is definitely a viable option. The basic skill a competent data analyst must have, like He should be a better understanding of business or a research. He should be a good SQL programmer or a Python programmer, or some who can dig out the insights from the data, report design and implementation, and also of dashboard development. Because what we visualize, we can gain more insights from the data. Lastly, data scientist. The nature of the work demands a deep understanding of mathematics for data scientists, not for data analysts. Means understanding of math is important for both the terms, but it is more important in the scientific term. A data scientist should also know about applied stats and programming. And are a few skills common between a data scientist and an analyst are ability to query database. They both work on a database. What are the soft skills they need? A programming in a statistical package such as R, Python, SAS, Julia, SPSS. Able to clean, extract, and explore data from different sources. They also require to research, design, and implementation of statistical models. Deep statistical and mathematical knowledge should be there. The big data, people normally confuse the role of data scientist with that of the data architect. In reality, the difference is quite simple. A data architect defines the tools and the architecture the data would be stored at, whereas a data scientist uses this architecture only. Of course, a data scientist should be able to set up new tools if needed for ad hoc projects. It is on his behalf. Now we comes for data cleaning. We have gathered the data, we have modeled the data, we have developed the methodology, what is the data scientist and data analysis, we have differentiated between them. Now, how we clean the data? Data cleaning is a technique that is applied to remove the noisy data. You can see from the picture itself here. Data cleaning involves transformation to correct the data, wrong data, that is in particular. Data cleaning is performed as a data pre-processing step while preparing the data for a data warehouse. Means knowledge from database to a knowledge. You can see the steps over here. There is a database. We are doing the data cleaning on a data warehouses where the data is integrated. Data is integrated in all the sections. Task relevant data, we have to dig out the task relevant data, data mining or pattern evaluation, and the knowledge. From databases to knowledge. That is the particular section that is data cleaning. What we want, that has to be cleaned from this one. Now, after cleaning, a data should be consistent with other similar data set in the system. Like the inconsistencies detected or removed may have been originally caused by some user entry that has done been in a wrong manner. Data cleaning differ from data validation. In that validation, almost invariably means data is rejected from the system. Okay. Now, the data consistency refers to a usability of data. That has to be in different types, means the 4 or 5 steps are into this one. Point in time consistency means it is an important property of backup files and a critical objective of software that creates backups. Means point in time is related to backups. It is also relevant to the design of disk memory system, specifically related to the what happens when they are unexpectedly shut down. If the system is unexpectedly shut down, what has to be happen? Means we have a consistent backup plan. Second is counter example. Assume Wikipedia database is a huge file, which has an important index located at 20% of the way through and saves article data at a 75% mark. Consider a scenario where an editor comes and creates a few articles at the same time. A backup is being performed, which is being made as a simple file copy, which copies from a beginning to the end of the large file and does not consider data consistency. And at the time of the article edit, it is 50% complete. That is known as counter example. This is a counter example, means 20, 25% or 75% of the data. Disk catching systems, that is the third part. Point-in-time consistency is also relevant to computer disk subsystems. Specifically, operating systems, file system are designed with the expectation that the computer system they are running on could lose power, crash, fail, or otherwise cease operating at any time. When properly designed, they ensure that data will not be unrecoverable, corrupted if the power is lost. Operating system and file system do this by ensuring that data is written to the hard disk in a certain order. Now is transaction consistency. Consistency comes in transaction also. In the realm of distributed database system, refer to the property of many ACID databases to ensure that the result of a database transaction are visible to all nodes simultaneously. That is, once a transaction has been committed, all parties attempting to access the database can see the result of that transaction simultaneously. Application consistency, on the other hand, in comparison to transaction, similar to transaction consistency, it is applied on a broader scale or larger scale. Instead of having the scope of a single transaction, data must be consistent within the confines of many different transactions. That is application consistency. Now comes to the heterogeneous and homogeneous sections. What is heterogeneous and what is homogeneous? Homogenization, like it involves translating different language to a language where we have more data. The quality of translation service is acceptable. But if we would like to translate massive amount of data with an API, the cost would be significant. There are software tools available for this task, but that would be costly too. On the other hand, heterogenization would be the possible to develop a solution for each language. In first, we are converting to a particular language, but in second, we are creating the for each language. As it is simple to detect the language of a corpus, we could develop a recommender for each language. Now, the most important part is missing data. How could we deal with the missing data in the data gathering or analyzing? Missing data is always a problem in real life scenarios. Areas like machine learning, data mining face severe issue in the accuracy of their model prediction because of poor quality of data caused by missing values. In this area, missing value treatment is a major point of focus to make their model more accurate and valid. Missing value replacement policies, like what we have to do if we have a missing values. As the diagram shows, we have the blank is 83% blanks, 1, 2, 3, 4 is nothing. How do we deal with this such type of missing? Ignore the record with missing values. This is the simple step. Replace them with a global constant. We can replace them with the global constant values like hyphen, question mark, or parallel values. Fill in missing values manually based on your domain knowledge. You can fill in the missing values. Replace them with the variable mean if numerical or the most frequent value if categorical. This is the point. And use modeling techniques such as nearest neighbor, Bayes rule, decision tree, or EM algorithm for handling the missing values. Types of missing data. There are three types, like missing completely at random. If there is no complete data, values in a data set are missing completely at random. This is normally known as MCAR. If the events that leads to any particular data item been missing or independent both of observable variable and of unobservable variables, parameters. When data are MCAR, the analysis performed on the data is unbiased. We can't do the biasing on that particular. It should be unbiased. And however, data are rarely MCAR. We don't have such type of data. It is rare part which we have unbiased data. In the case of in this case of missing completely at random, the missingness of data is unrelated to any steady variable. Thus, the participant with completely observed data are in effect of random sample. Okay. Next is missing at random, means completely and at is a different domain. First is completely and next is at random. Missing at random means it occurs when the missingness is not random, but where missingness can be fully counted for by variable where there is complete information. It is an assumption that is impossible to verify statistically. We must rely on its substantiveness. Okay. An example is that males are less likely to be filled in the depression survey, but this has nothing to do with their level of depression after accounting for maleness. That is like the missing at random. Last is missing not at random. Missing not at random means also known as non-ignorable, non-responsible, is data that is neither MAR or MCAR. The value of the variable that missing is related to the reason it's missing. We have to find the reason why it is missing. To extend the previous example, this would occur if men fail to fill in the depression survey because of their level of depression. Now we are counting the level of depression. In the previous one, we are not counting the level of depression. This is something we have the glimpses of types of missing data, means how to deal with the missing data now. Techniques of dealing with missing data. Number one is imputation. Imputation means some data analysis techniques are not robust of missingness, means and required to fill in or impute the missing data. We have to impute some value there. For example, Rubin argued that repeated imputation even for 5 times enormously improves the quality of estimations. For many practical purposes, 2 or 3 imputation capture most of the relative efficiency. However, a too small number of imputation can lead to a substantial loss of statistical power. That is not viable. Next is interpolation. Interpolation is in the mathematical field of numerical analysis. Interpolation is a method of constructing new data points within the range of discrete set of known data points. That is interpolation. Next is partial deletion. The method which involves reducing the data available to the data set having no missing values include like list-wise deletion, case-wise deletion, pair-wise deletion, means we have the pair of the students from Delhi or from UP, we have to delete the pairs. Or the student we have with the low IQ, we will delete those list. Full analysis, method which take full account of all information available without a distortion resulting from using inputted value as if they were actually observed, means generative approaches and discriminative approaches. Generative approaches means the expectation maximization algorithm or full information maximum likelihood determinations or estimations. On the other hand, discriminative approach like max margin classification of data with absent features. What are the features absent from the data? We have to maximize those margins. Next is data transformation process. How the data is transformed. Data transformation is a process of converting data or information from one format to another, usually from the format of a source system into a required format of a new destination system. The usual process involves converting documents, but data conversion sometimes involves the conversion of program from one computer language to another to enable the program to run on a different platforms. The steps what we involved in data process, like data discovery, you have to discover the data, what type of data is there. Data mapping is the process of defining how individual fields are mapped, modified, joined, filtered, and aggregated to produce the final desired output. Next is code generation, is the process of generating executable codes in any of the language, whether it is SQL, Python, R, on which language you are working on. Fourth one is code execution. What we have written in the code generation, we have to execute in the code execution part. Is the step whereby the generated code is executed against the data to create the desired output. And the last and the most important is data review. What we have done in data discovery, mapping, generation, execution, we have to review in the last. is the final step in the process, which focuses on ensuring the output data meets the transformation requirement. That's all from my side on data sharing and gathering and analysis, how we gather the data and how we analyze the data.
Okay, that was quite insightful. You started with the CRISP TM and then included at cleaning missing data. That was very nice. We have few of the questions, Professor, with us, and I would like you to take those questions. And guys, the attendees, if you guys have questions, please type down your questions on Q&A, and we'll take it one at a time itself. All right. So, okay. So we have Gaurav who's asking what are the parameters and hyperparameters for machine learning model. Now Gaurav has just jumped a few steps ahead. He's directly reached into modeling and evaluation part. Would you like to take this question? I don't think so that covers this, but yeah, you can go ahead with it.
I can briefly give the insight what are the parameters and hyperparameters.
Yeah.
Model parameters, like these are the parameters in the model that must be determined using the training data set. These are the fitted parameters that are already fitted in the training data set. And the hyperparameters are those. These are adjustable parameters that must be tuned in order to obtain the model with optimal performance. We can tune the hyperparameter. These are the user-based parameters. We can tune like, and model parameters are the fitted parameters. These are fixed parameters.
Great. And those of who doesn't know about CRISP TM or CRISP ML, these are quite important itself. Even each step is quite important, and obviously, I believe Professor, like it would take you another 2-3 hours to explain CRISP DM only, right?
Yeah,
it has so there your question, Gaurav, parameters on the parameters and hyperparameters, you would get a better answer itself on that. So, with the constraint that we have it on our hands for this session, which is we try to make it shorter, right? So it's not possible currently, but I'm sure during the program we cover all these issues itself. All right. Thank you for asking that question, Gaurav. We'll go to the next question. That is Shubham, who's asking how to manipulate a data.
How to manipulate? That is a good question, and I answered in the part of types of data missing values. Means you have to ignore that particular value, or you can put a random number there, like a random variable, a question mark or a hyphen mark that has to be discarded, or you can put the mean or average value of all the data that has to be presented in that particular field. You can take the mean of that particular field and put on everywhere where the data is missing. That can in the way that we can manipulate the data, but it's not recommended to manipulate at a major extent. It is, we are dealing with the missing values. Where are the missing values in the less number of amount? That is a good one.
Yeah, thank you for that answer. Actually, if you start manipulating his data, your results will be quite results actually get varied actually. We have anonymous attendee who's asking, how will I know if the end result is accurate? Now, this is a quite interesting question.
This is a quite interesting, Rohit. We have started with the data gathering and the problem definition. You have seen that slide in which we are covering from business problem definition, in the life cycle of big data, business problem definition. And I have told him that if the implementation result is as per as our problem definition, then we can say that our end result is accurate. That is the only definition. Whether it is accurate, 100% accurate or 80% accurate, what we want to achieve in our problem definition, if we have achieved in the last implementation phase, then our end result is accurate.
Yeah, and
accuracy.
Yeah, and talking about accuracy, in any model that you create, you can never attain 100% accuracy. You would always aspire to get it, but yeah, that is something that I believe, Professor, we ourselves set, right? Initially, we have to set our accuracy that, okay, if we get, let's say 70% of 70% and above, and we are well to deploy this model, If we get lesser than 70, then there are other processes that you can improve it and other things. Okay, perfect. Thank you, anonymous. Sorry, attendee who's not sharing his name. No problem. We've got okay, Abhishek, right? He's talented and he's asking how to become a data scientist. And I can see he's got series of questions. What skills? So I'll accumulate all the questions at once. So he's asking how to become a data scientist. What skill needed for becoming a data scientist, and what are the platforms or learnings are required to be a data scientist?
Yes, we have discussed the differentiation between the data scientist and the data analyst. So we have discussed he should be a programming status. He should know the programming basics, programming like R, Python, SAS, SPSS, Julia. These are the programming that has to be he or she should know, and he should also know the how to clean, extract, and explore the data from the raw data, what we are gathering from the unstructured data from the different sources. He should know how to make a structured format and in one single type of format of the data. And he should also know how to research, design, and implement the model. Means he should not copy paste. He should know the maths and something behind the that particular algorithm and the model. And then the last, he should have a deep statistical, mathematical, and computer science knowledge. Then only he can, or she can become a data scientist.
Yeah.
And then can be accumulated. You can, these are not pre-born, you can accumulate all these knowledge as the time passes.
Yeah, even during my studies also, I heard it from my professor also. He said a data scientist is someone who has better statistical knowledge than a coder, and who has better coding knowledge than a statistician. So
Yes.
that is what a data scientist is.
Is.
I believe, Abhishek, that that answers it. So if you think of becoming a data scientist in the future, one thing is you need to have your hands dirty in both. You have to have understanding of coding. You have to have an understanding of statistics, and that's what is going to make you a better data scientist. And then that is when companies are going to look up to hiring you as a data scientist in their organizations. I believe that is it. That is all we have. That is all the questions that we have.